Hi, my name is Leo. I also work with Adam and Mitchell, and this is realistic real-time rendering of real scenes using ray tracing. So this is a live demo of our real-time ray tracer. As we can see, we're in Berkeley right now. There's just the environment map, but if I turn to the side, we can see a Cornell box with some interesting stuff inside. You can see I can traverse around the scene in real time. It does seem to speed up and slow down depending on what I look at. So if I look at the ceiling, it's maybe going at 30 FPS, but then I look at some glass and it's down to like 10 FPS. And that's basically because we do rasterization for all the diffuse surfaces, so I can actually turn off ray tracing and just look at what's not being ray traced. And we can kind of look around and see, hey, why isn't this stuff being ray traced? It's because we've baked all the textures in before the rendering process and saved basically all the textures for all the diffuse elements in the scene, which is pretty cool. So we can just rasterize those using OpenGL. And then everything else that, like, such as the reflective surfaces, the glass, that needs to be ray traced, which slows it a bit, but still we can kind of traverse through it in real time, and it gets really slow as we get closer to glass. Glass is pretty much the most expensive thing just because each pixel takes a lot of rays to generate it. Mirrors are better, but still pretty intensive. It is pretty cool that we can just like move around the scene in real time. It's kind of like a video game, but it looks, has perfectly realistic shadows, perfect caustics, and that's a bit of an interesting problem. We basically do bidirectional ray tracing during the baking process, which means we shoot out rays from the environment map, mostly from the sun, just because of that's how the light sampling works. But rays come in from the sun, they bounce around this scene, and whenever they hit a diffuse object, they bake the irradiance at that point, which is how we can basically get sun coming in through the window, off a mirror, through this glass cube, and then onto the wall behind it, and actually get realistic caustics from that, which is very cool. And this whole scene maybe takes maybe around 30 minutes, but you could get a decent looking one in a few seconds or a minute or so that just is noisier. And then you could get no noise if you baked for even longer. Moving on to the realistic reconstruction side of our project, you can see here we have a 3D scan bedroom, and we're traversing it in kind of pseudo real time. I had to shrink the resolution down a bit, and we're not using any texture baking. This is kind of just classic ray tracer on our reconstructed image. Basically, is reconstructed using OpenArc, which is Berkeley made software that Adam on the team developed. And it works pretty well at a lower resolution. We're getting like 2 FPS. So that's just using no optimizations. And we can see we do get, actually like ray traced lighting and stuff, which is nice. So let's change it up a bit and see how to optimize it. Here you can see the same bedroom, but everything looks a bit more pixelated, maybe Minecrafty. That's because we kind of cheap out on actually baking the textures. We basically can't make a texture for this many triangles. There's almost 200,000. So instead, we just assign a single color to each triangle, which allows us to draw them much faster in a kind of a realistic time frame, which allows us to traverse this scene in real time too, which doesn't really look as good, but is necessary if you want to basically bake textures for a scene like this. So next I want to show how to do reconstructed objects placed into a virtual world. So here's my face in our Cornell box, and I actually just scanned my face and applied 3 different materials to it. 2 are ray traced, 1 is actually diffuse and using the baked single color per triangle method, which is why it does look a bit pixelated. If we pause on it, you can kind of see it is noisy. The noise is just from not baking long enough, but you can actually see the divisions on the triangles too, which is simply because we can't have a texture for each triangle because each face is 50,000 triangles, which means 150 draw calls per scene, which means if they're textured, then that just wouldn't be possible. So that's pretty much it. I would encourage you to go to our GitHub website so you can see how we did everything. We go into a lot more detail, have some more cool demo videos to show you that wouldn't otherwise fit here, and that's pretty much it.